This is Java OCA Unit 4, Lecture 1, and in this lecture we will discuss the string class. In this lecture we will discuss constructors of the string class, immutable properties of strings, and methods of the string class. Strings are immutable objects. Once instantiated, the contents of a string object cannot be modified. And you'll notice on the right, I have some code with strings 1, 2, and 3. They all store the word hello, but you're going to notice some different outputs that are generated. Here on line 8, we have a printout of string 1 with the double equal sign string 2, and it prints out true. We see it's right there. And then on line 9, the second thing printed out is comparing string 1 to string 3, and it prints out false. And we say, well, they all store the word hello. Why does one print out true and the other print out false? And when we initialize strings, if they exist in memory, the Java virtual machine, being as efficient as it is, will automatically assign the same pointer to the other variables. However, in string 3, we use that word new, which instructs the JVM to allocate a new memory location. And the new memory location is going to store the string hello. Even though it has the same characters as string 1 and string 2, it was told to find a new memory location and to set that up and store those letters there. And if you look further, I printed out the hash code for string 1, string 2, and string 3, and that's what we have down here. And we see that string 1 and string 2 have the same hash code, also could be thought of as a pointer, and string 3 has a different hash code. For this reason, string 1 equal to string 2 prints true, and string 1 equal to string 3 prints false, and that's using the double equal sign. It does not compare the contents. That would need the string method .equals to do that. It only compares the memory location. So now if we look at line 13, we see that string 2 has an update to it. It's a concatenation update, and it's adding the words and goodbye. So now string 2 will be hello and goodbye. And you'll notice that string 2 now has a different hash code or memory location. And the reason for this is that every time you modify a string, Java will construct a whole new string from scratch. And that's what we mean by immutable objects. That means it doesn't take the current object at its memory location and modify it. Every time you modify a string, it creates a whole new object which exists in a completely different memory location. And that is what we mean by immutable. That being said, our lesson after the string class will be the string builder class, and those will be strings that you could modify. They are mutable strings. So the JVM manages the assignment of string memory addresses to its respective variables, and since strings are immutable, the JVM does not have to worry about the contents of a string changing, and this allows for it to run more efficiently, without error, without crashing, and that's the purpose of a string. It is an immutable object that holds a sequence of characters. So when a string object is instantiated, its contents are stored in a private variable, which is a character array. And since arrays are of a fixed size, they cannot grow or shrink once they are initialized, and this means that a string cannot change size. Further, the character array is final. And none of the methods of the string class deal with modifying string contents. So this means that even if the string length were to remain the same, there's no way to alter the contents of the array. Therefore, strings are unchangeable, hence immutable. And here we see an illustration where the word hello is going into the constructor, and the constructor has a private final character array whose name is value. And the value array is holding each character of the string object in its separate location. Notice that they are using single quotes for the characters in the character array. And this is the process that happens with a string construction. And this is why we work with string indices starting from 0 up to 1 less than the length of the string, because it is going to correlate with the way that arrays handle indexing. So here we have some examples of instantiating strings. You can start with the most common one, which is to set a string equal to a literal string. Or you can use a string constructor, which accepts literal strings, or it accepts an array of characters. And then you have three different ways you can set up empty strings. You can also initialize a string to store null, and null is the default stored for a string object. And if you make a string array without adding anything to it, it will be storing a bunch of null values. Finally, as a word of caution, you want to be careful when strings are storing null, because then you cannot use any string methods because there's no memory address pointing to the string object that needs to be interacted with the string methods. So this will throw a NullPointer exception error. Back to the topic of equality, you have the double equal sign version of equality, and you have the string method dot equals. And the double equal sign is going to compare memory pointers, and the dot equals is going to compare string content. And if we go back to the example we've been looking at, string 1 and 2 have the same memory location, so they give us a true result. String 3 has a different memory location, so it gave us a false result with string 1. But string 1 and 2 with the dot equals method returns true, as does string 1 and 3 with the dot equals method return true, because they're storing the word hello. Now, just to check your understanding here, we have some lines of code. Word 1 stores Java, word 2 stores Java, word 3 stores Java program. If we compare word 1 to word 2, we expect this to print out true. If we compare word 1 dot equals word 2, we expect this to print out true. But now we get someplace a little bit different here. We see that word 4 is going to take word 3 and substring. It's going to construct from index 0 up to 4, not including index 4. Remember, that's how the substring method works. So we start with the index 0, 1, 2, 3, 4, but we're not going to include that space at 4. So it's going to construct the word Java. So word 4 is storing Java. Will line 7 print true or false? And the answer here is false, because anytime a method is constructing a string, it will use a new string constructor with a new memory location. It will not look for that string to be in memory already. And if we compare word 1 to word 4 using the dot equals method, it will print true because they store the same sequence of characters. And we'll go through a couple of the string methods, and I'll leave the rest of them for you to do on your own. The first one is character at, and we see that we have a word called race car, and it says to identify what is returned by word.character at index 1. And you'd say, well, 0, 1 would return a little a. Word.character at 3, 0, 1, 2, 3 would return the little e. And word.character at 6, 0, 1, 2, 3, 4, 5, 6 returns the little r. And now we want to look at when can our code cause an error using the character at method. So if you look at the word hello, and it says which of the following will cause an error. Word character at 0 is fine. Word character at 1 is fine. 2, 3, 4, there is no index 5. That would cause an error. The length of the word hello is 1, 2, 3, 4, 5 long. That would cause an error. And character at word length plus 1 would be 6. That would cause an error. So we have these three down below cause errors. They will produce a string index out of bounds exception error. So we want to make sure that the index is within the range of values that are acceptable. So our next method up is the index of method, and you can see it has two different parameter types that it accepts, a character type or a string type. This is an overloaded method. And overloaded methods are our first introduction to polymorphisms. And given the word race car, we want to know what is the index of lowercase e, and this will return the first instance. If there were multiple e's or multiple, say for example, if we were using a, it would return the first one, but there's only one e, so we're going to say 0, 1, 2, 3. It would return a 3 for e. Index of car, well, we see that car starts at index 4, and that's what it would return for car. So the second example is the type that receives a string, and it looks for the first character of the string if the string exists in the word. And then index of s, since there is no s in race car, it would return a -1 because it is an invalid index. We know that that is not existing in the word. And we see that index of is overloaded even further because now it accepts two parameters, the first being a character with an index value or a string followed by an index value. And this is to account for multiple times that a character or string shows up in a word. So if we're looking at the first example, our word is Mamma Mia Pizzeria, and the index of m starting at 3 or later. So we say, okay, 0, 1, 2, 3. 3 is an A, so the first M that starts at 3 or later would be at index 4. Now we have a string, MA, ma. When's the first time that occurs after the index 1? We see, well, index 1 is A. Ma occurs at 2, 3, so it's going to return 2. And then IA, starting at index 6. So we have an IA at 5. We're starting at 6. This space counts as 7. 8, 9, 10, 11, 12, 13, 14 is what it's going to return because there is an IA at the end of pizzeria. And that is the 2-parameter version of the index of method. It allows you to look for later occurrences of a character or string. So now I want you to write a simple program that uses a loop with the methods that we've discussed already. So at this point, you're going to write a simple program that is going to use loops with the string methods we've discussed already. And in this example, you see that the word we're using is Mississippi, and you're going to find how many times a letter exists in Mississippi, and you're going to return the proper output listing all of the indexes where the letter exists, or stating that the letter does not exist. So if we're looking for the letter I in the word Mississippi, it should return 1, 4, 7, and 10, because that's where the I's exist. If we're looking for the S in Mississippi, it should return 2, 3, 5, and 6, because that's where the S's exist. And if we're looking for the letter Z, it should say the letter Z is not in the word Mississippi. Pause here, write your program, see if you can accomplish this, and then when you unpause, my solution is going to be shown on the next slide. Okay, so here is my solution for the program that you just saw on the previous slide. You see I start by setting up the word that I'm going to be searching, in this case Mississippi, and the character is set to Z, but you would change this to I or S to run each of the outputs. And I'm building a response to be printed at the last line. See, response is printed when we're finally finished with this program. And here it says the response is the letter, and then CH is equal to Z. So the letter Z is found in the word is Mississippi. And then here is our new line, /n. And on the new line, it'll say at positions with a colon space. And it sets the current index to 0 for our search. And we have an if statement saying that if the letter we're searching for returns a -1, then we're going to change the response of the output to be the letter Z is not in the word Mississippi. And the while loop would end up breaking out because we'd get a -1 and it would go down and print. However, if this were an I instead of a Z, then the if statement would be false. It would come down into the while loop, and it's not going to return -1 because we know there's an I in there. We're going to come down and response is going to be updated with the first instance where the letter I exists according to the current index, which is 0 at this point. And from there, we're going to go up and say now that we've added the location of I, current index is going to take the index of I. So in Mississippi, the index would be at 1. So it's going to take the index 1 and it's going to add 1 to it so that the new current index starts at 2. And then it's going to start from 2, searching for the next case of I. It comes back up, loops through. It'll find I at 2, 3, at 4. And it'll print here. We have the response now says 1 with a space, 4 with a space. It'll come down. It'll update the current index to be 4 plus 1, which is 5. So it'll start from that S. And it'll keep going through this, and eventually we'll get to the point where there's no more i's and it returns a -1, or we reach the length of the word, and we leave this while loop, and we print out, and we'll say the letter I is found in the word Mississippi at positions. Again, that's going to be down on the second line, and it'll print all of the positions after the colon. So there's my solution using loops with the string methods that search for the index of a specific character. And you can use this to search for not just characters, but whole strings. If you were creating a program that worked with a word processor and had to find all the instances of a word so you can replace it, you would use this type of strategy to do that. Also, for the Java OCA exam, you need to be familiar with the 2 versions of concatenation. We've been using the plus sign or the plus equals to update strings through concatenation and loops. But you can also use the .concat method, and they accomplish the same thing. And you see I have a simple program here, and they use both methods and produce equal outputs. String 1 .concat, string 2 .concat, string 1. We can use multiple methods in a series with the dot operators connecting the methods, and that would give me hola means hello. And then we have it here with the plus sign as a concatenation operator, also printing hola means hello, and we have the output printed out in the terminal window below. And next is the compare to method. This is an important method for alphabetizing the order of string objects, and often you would use this for sorting arrays so that we can then search them. And I have the program written on the right where we have a bunch of fruits that are being stored into a string array, and then it prints the fruits before they are sorted, and we see here's the output, fruit array before sort. We have peach, boysenberry, cherry, apple, avocado. And then as we go down, we see that it does the sort method, and if we look down at the sort method, this is where it's using the compare to method in the if statement so that we could then do a swap of string objects to put them in alphabetical order. And we have here the fruits after they are sorted. Now, the compare to method takes the first string, which is connected by the dot selector, and the second string, which is inside as a parameter, and it compares them. And here we see that the outside string is 2 before the inside string in the order of the alphabet. That was a single letter comparison of strings. Notice the double quotes. Now we're going to look at a word, and I use the word ABC compared to ABD. And because the first letters are equal, it goes to the next letters and compares. Those are equal. And finally, on the third letters, it says the word out here is 1 before the word on the inside, so it returns a -1. However, instead of ABC, if this said ABE, it would have returned a +1. So we use the negative and positive return values to know what comes before or after so that we can sort. So here we have a list of string methods on the Java OCA exam. We've looked at the character at, the index of, we looked at concat, and we looked at equals and compare to. You should know substring from your Java AP Computer Science course. You should know .length from your Computer Science course. And the ones that, if you haven't seen them, that you need to go out and study are trim, replace, ends with, and starts with. They are in your Java OCA textbook, pages 229 to 238, or you can use any other means you want to study for them. So this is the end of this lecture. If you need to, go back, watch it again, and then complete your online assignments and submit them, and move on to the next unit.